All right, so let's speak about leads now. All right. In all honesty, this discourse can get a little complicated, so we're going to keep it simple because you don't need an advanced understanding of leads to read a 12 lead ECG. All right. So let's start off by categorizing the leads. All right. So you have limb leads. Oops. You have limb leads. All right. And you have precordial leads. And limb leads can be bipolar and they can be unipolar. And all precordial leads are unipolar. So what do we mean by this? Bipolar limb leads have a negative side and a positive side, whereas bipolar limb leads just have a positive. So the other is the ground. Okay. Yeah, so that's obvious here as well. And so, okay, tablet is tweaking. Just one sec. Okay, I don't know why it's tweaking, but anyway, good. So then let's talk about the bipolar leads. These are leads 1, 2, and 3. Simple enough, right? And then the unipolar leads are the unipolar limb leads, that is AVL, so AV left side, right? So AV means augmented voltage. So augmented voltage left, augmented voltage right, and augmented voltage foot. Right? Simple enough. And the precordial leads are V1. Okay, let's just make it easy. V1 to V6. Okay, great. All right, so let's break this down some more. Okay. To do so, we're gonna have to bring back our guy. Probably we should give him a name. I don't know. We could name him Ralph or something. All right, so this guy's Ralph. How do you spell Ralph? Yeah, Ralph. Ralph Lauren. So Ralph. Okay, all right. And Ralph has his electrodes on him, right? So left arm, right arm, right foot, left foot. So first things first, right? The right foot is always a ground. So we can eliminate it from our analysis or interpretation, right? Now the leads, so let's write them out. Lead 1, lead 2, and lead 3. I remember these are the bipolar limb leads. They are created by combining any two electrodes, making one negative and another positive. Okay, so lead 1 is a combination of a negative right arm and a positive left arm, right? So what that means is any current going in this direction is gonna give you a positive deflection, and any current going in that direction is gonna give you a negative deflection. All right, so that's how you get lead 1. All right, let me make this a little smaller. Okay, now lead 2 is created by making the right arm negative and the left leg positive. Remember we said the right leg or right foot is eliminated, right? It's just a ground or a 0. So forget about it. So that's how you get lead 2, and therefore any current going this way is going to give you a strong positive. All right. And then finally, lead 3 is created by making the left arm negative and the left leg positive. Right? So currents going this way will give you a strong positive. Right? So what's this all about, really? Let's erase Ralph, unalive him, right? And when you plot the, if you want to call it the axis, yes, that's the word. When you plot the axis of these leads on a graph, right, what you get is this. Lead 1 would look like that, right? It's going from right to left, right? That's how the energy would, or the impulses would be picked up. And then lead 2 is also going from right to left, but down this way. And then lead 3 is going from left to right, this way. And there are actually degrees associated. So lead 1, hold on, so this should be negative, positive, negative, positive, right? So lead 1 is 0 degrees, right? Lead 2 equals 60 degrees, and lead 3, so going this way, lead 3 equal 120 degrees. Okay, so I hope you can conceptualize that. All right, so right arm to left arm is a straight line, and that line is the 0. Right arm to left foot, right, is a downward diagonal from right to left. And then from left arm to left foot is a downward diagonal slightly going from left to right. Okay, you can think of it as your arm is more lateral or more outside of your body than your foot. All right, so let's talk about the unipolar limb leads, right? So our unipolar limb leads are AV left, AV right, AV foot. Okay, great. So how do we get these leads? So let's go back to our limb electrodes. Let's draw Ralph again. Okay. Alright, Ralph. And you got right arm, left arm, right foot or leg, left foot or leg, whatever. All right. So what happens with the unipolar leads, as I said, there's no negative, there's only a ground or a 0. So what these genius ECG dudes, right, from back whenever, what they did was they made all of the other electrodes be 0 and one electrode be positive. So basically you have a mean electrical vector going this way. Well, let me not say a mean electrical vector. That is the axis which that lead would record an impulse best, right? This axis here, or this angle, right? Cool, you seeing that? So AVL is going up and to the left because it makes all of the others a 0. Okay, so by convention you can see that if I make everything else and I make the right arm positive, it's gonna go up and to the right. Cool. And then finally, right, if I make everything else, did I say everything else negative? I meant everything else 0. If I make everything else 0, right, it should go down and to the left. But remember, the heart is on the left side of the body, so it's actually straight down. That's what that vector looks like, right? So, or that's what that axis of analysis, or the axis of the sensor is like, right? So let us now put these on a diagram. What you end up is with a diagram something like this. So this is 0, and then you get AVF, all right, at 90 degrees. So anything going straight down is gonna give you something like that, right? AVL is here, so this is 0, right? And by convention you go clockwise. So anti-clockwise, this is actually in the negatives, all right? So AVL is actually negative 30, all right? And then AVR is over here, and some people call it, you know, so this is supposed to be 180, so some people call this thing negative 150, whatever, right? The point is, this is negative 30, this is 90, okay? And okay, this is negative 150. I think we can agree on that one. I just feel like I'm leaving something out. Let me see. Okay. So, oh yeah. So any impulse that's going to the left, especially to the left and up, is going to be a strong positive, and anything going to the right, especially the right and up, will be a strong positive in AVR, right? I hope I'm not going too fast here. Let me slow it down. All right. So based on the diagram on Ralph, we're able to see how the leads would be positioned, and now we're able to draw those positions on a simplified diagram which shows the angle or the axis which the leads sense electrical activity maximally. All right, and we say AVF is 90 degrees, AVL is negative 30, AVR is negative 150. All right, now let us complete this diagram, right? So this diagram is called the hex axial diagram of limb leads. Hex meaning 6, right? So lead 1 goes that way, lead 2 goes that way, lead AVF goes that way, hold on, lead 3 goes that way, lead AVL goes that way, and lead AVR goes that way, right? So let's write them all in. So basically the front of the arrow is pointing in the direction that the positive electrode would be placed, okay, in all of these. So this is lead 1, this is lead 2, this is AVF, this is lead 3, this is AVR, and this is AVL. And we're gonna fill in the angles. So negative 30 degrees, 0 degrees, 60 degrees, 90 degrees, 120 degrees, negative 150 degrees. All right, so that's the leads in a nutshell. There's something else I need to bring back to your attention, and then we're kind of done with leads for now, and that is this. If I have a lead, for example, lead 1, there's two things I need to bring to your attention actually. So I need to bring to your attention the mean electrical vector of the heart also. Okay, anyway, so if I have lead 1, right, I may have a vector going exactly this way, or I may have vectors going, oh, let me put a positive electrode here and a negative electrode. So I may have a vector going that way, or I may have a vector going that way, or that way. For example, just for argument's sake, what we're saying is once the vector is going on this side of the half, right? If I was to separate this viewing field of the electrode into two sides, right? One side is towards the electrode and one side is towards the positive electrode and one side is towards the negative electrode. Anything going towards the positive electrode, even if it's not going in the exact axis, it's still going to record a positive impulse on the graph. It's just that it either may be smaller or it may be kind of biphasic, but it will be predominantly positive, right? In contrast, any impulse going that way right, so on the other half will be predominantly negative. So it will either be big negative or, oops, going too fast because that's clearly not a negative. It will either be big negative or just predominantly negative, but it's going to be negative. So that same concept goes for all the leads. All right, so let's use a lead that's at an angle like lead 2. What we're saying is, sorry guys, but this is a little bit of math, right? So if I got lead 2 and I split it, I split this thing in half, right? Lead 2 is 60 degrees, right? So then to get this perpendicular, this would have to be 30 degrees, right? And let me see, this is 90 degrees, right? So from 60 to, because basically a perpendicular angle is 90 degrees. So from 60 plus 90, this would have to be 150 degrees. All right, get that? So all perpendicular angles are 90 degrees from wherever you're starting, right? So to get to 90 degrees here, right, it would be 60 plus 30. but by convention it's negative 30. And to get to here, right, it would be, hold on. Okay, I see how that explanation could have been a little bit confusing. So let me say it in another way. If I'm going counterclockwise, I'm going to subtract 90 degrees, right? So 60 minus 90 is negative 30. But if I'm going clockwise, right, I'm going to add 90 degrees. So that's how I got the 150, okay? All right, sometimes I'm thinking faster than I'm speaking, so it's not making sense. Anyway, so I'm glad, I hope that's clear. So what we're getting at is, for lead 2, anything that's going this direction, so in the direction after negative, in the direction after 150 degrees or after negative 30 degrees, would show negative on the lead 2 diagram. But anything on this side between negative 30 and positive 150 would show positive. All right, so I think that this is something that may come across as a little complicated, but it's simple somewhat, right? So the point is, again, whatever the lead you have, let's say you're using AVF, which is another simple one, anything that is past 90 degrees from it, so if something is going this direction, it will be negative, right? And if it's less than 90 degrees from it, like here, it's going to be positive, right, on either side. Okay, so that's just a concept you need to understand. It kind of gives you, it gives you an idea of where the impulses are originating or where the impulses are traveling in comparison to the lead that you're looking at. All right, good.